is the last lesson of 9.5. This lesson is about the kidney and how to make pee. In the middle here, you see the functional unit of the kidney, which is the nephron. Here's the nephron, and you can see it's covered in little capillaries, which pick up water and ions to come back to the body from the interstitial fluid. In mammals, urine is hypotonic to the surrounding body fluids. And really here we're focusing on water conservation and balancing of different ions and making waste be excreted. So here's some features. The loop of Henle. The nephron has different parts that have different permeability. If you remember the concentration gradient, that drives the passive transport and active transport, which makes some of the water and the other ions move back and forth from the nephron to the interstitial fluid to be reclaimed by the body, or vice versa. There are three parts to it. One is filtration, second reabsorption, and third secretion of waste. So first, let's look at the Bowman's capsule. This is where filtration occurs. So you can see the blood coming in by the incoming arteriole, and there's a certain amount of pressure that makes the filtrate go into this Bowman's capsule. What's held back are large molecules and blood cells. So you can see the outgoing arteriole, you still have blood going out. So the blood comes in, the blood comes into the Bowman capsule, and a lot of the liquids are pulled in to the kidney at this point. Okay, so different things like water, ions, small nutrient molecules, as well as waste come in to the Bowman's capsule at this point. It's sort of like if you've ever made coffee, you have coffee grounds, and the coffee grounds stay in the filter, and the good tasting coffee goodness drains out. So once again, the blood cells, platelets, and plasma proteins are too large, and they keep into the blood flow, and the rest comes into the Bowman's capsule. Lots of blood passes through the kidneys every day, and only at 1.5 liters is actually excreted from your body. All right, so here is the nephron in its different sections. We have the Bowman's capsule with the glomerulus. We have the proximal convoluted tubule, and the tube goes down, 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 around the loop of Henle, up, 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 ascending segment, and then different things happen at the distal convoluted tubule, and then through the collecting duct, and then out the renal pelvis to the ureter. So the fluid enters the proximal convoluted tubule, and that's where reabsorption occurs. So water, ions, and nutrients are transferred back to the interstitial fluid via passive and active methods. So there's some specialized ion pumps that transport potassium, sodium, and chlorine from the filtrate into the fluids that are surrounding the tubules. These will be collected by the blood vessels and taken back to your body. There's active transport proteins, which are embedded in the walls of the tubule. Those reabsorb amino acid, glucose, and other nutrients out of the filtrate. And urea and other compounds are not reabsorbed because the urea anyways is supposed to be excreted. So don't throw the baby out with the bathwater. When you let go of the plug, you want the water to go out, but you don't want the baby to go down the drain. So in the same way, when you have all these things go through the nephron, you don't want all the things that your body needs to be thrown out with the waste. So there's a process of filtering out the good stuff and reclaiming the good stuff, and then the rest will go out because it is real waste. So the inner walls of the tubules are covered with microvilli that increase surface area for reabsorption. These are used all over your body, including your small intestine. Anyways, the reabsorption process makes a filtrate that's in that tubule in the nephron hypotonic to the interstitial fluid, which causes water to flow out and into the interstitial fluid by osmosis. So you can see the proximal convoluted tubule, and the filtrate goes down the loop of Henle, and that's where a lot of water is going out. By out, I mean out into the interstitial fluid, which are reclaimed by the body. So in the proximal convoluted tubule, or the PCT, there are aquaporins. That's a membrane protein that passively transports water molecules. This is where most of the sodium, potassium, and chloride ions, as well as a lot of the water and some of the urea, goes into the interstitial fluid. So you can see in this picture, it becomes increasingly yellow looking because I guess it's supposed to show that it's concentrated. I don't know. The reabsorbed stuff enters the capillaries, and the remaining fluid has a high concentration of urea and other wastes that were not reabsorbed. Those moved into the descending loop of Henle. More water is reabsorbed by osmosis and aquaporins. As the fluid moves up the ascending loop of Henle, sodium and chlorine are reabsorbed into the interstitial fluid by passive absorption. As the fluid goes up the loop of Henle, the ascending portion of it, the concentrations of ions are high enough for reabsorption to happen by passive diffusion. And then towards the top, the ions are moved with active transport. So at this point, water, ions, and nutrients have been reabsorbed. Urea and other nitrogenous wastes have been concentrated in the filtrates, so the total volume is greatly reduced. So now we're talking about secretion. So the distal tubule, we're almost at the end here. Additional water and salts are removed. More ions and salts move out of the tubule, then into it, which causes more water to flow out through the aquaporins. The results of that will be a concentrated urea, and other waste flowing into the collecting ducts, which further concentrate the urine. Remember, when you're drinking and drinking and drinking, the goal is not to just pee it all out. So you don't want to have a really voluminous urine. So collecting ducts from the cortex go into the medulla, which are permeable but not to salt ions. It gets more concentrated and the water moves still out, greatly increasing the urine. Near the bottom of the medulla, that's the interior of the kidney, the walls of the collecting ducts contain passive urea transporters, which allow some of the nitrogenous waste to pass from the duct to the interstitial fluid, and this helps with the concentration gradient. So now we're at the last portion, which is secretions. So hydrogen ions are actively secreted. Any products of detoxified poisons from the liver are passively secreted, and many water-soluble drugs and their metabolites, such as penicillin and other medications, are also secreted here. The secretion of hydrogen ions helps to balance the acidity that is constantly generated in the body by metabolic reactions. At this point, it's coupled with bicarb ions, and then small amounts of urea are also secreted here. Additional active secretion of hydrogen ions happens in the collecting ducts, helping to balance the pH level of the blood and fluids. If the pH level of the body is controlled by the kidney, so then excess hydrogen ions can be excreted here. And then varying amounts of potassium and hydrogen can be secreted in the DCT. There's the nephron. And we're almost at the end. When the urine reaches the bottom of the collecting ducts, is 4 times as concentrated with waste as compared to the fluid surrounding, or the extracellular fluid, which is the fluid between cells. Here's the pathway. Collecting ducts to the renal pelvis, which is in sort of the middle of the kidney, to the thin tubes that go to the bladder, and then out through the urethra. I like this.